All right, so I'm going to try and whip through an intro to the graphs of trigonometric functions. We're really going to look at one today, and then I'm going to kind of let you explore what happens with the rest. But what are the domain and range of the sine function? So before we move forward, I want to give you a little bit of how do we create the sine function? How do we graph it? So let's utilize what we know about the unit circle and leverage that to help us create the sine function. So what I'm going to do is I'm going to create a little unit circle over here. And then I'm also going to create an XY axis for graphing, where on our x-axis we have radians, and on our y-axis we have y equals the sine of theta. So that's our relationship here. Okay, so how do we begin to start graphing points? Well, classically, when we've dealt with functions, we have an input-output, right? So if we have an input of theta and an output of sine of theta, we can leverage the relationship of what we know about the sine function. If you think back, we created something like this. Theta, the sine function is opposite over hypotenuse. So if I've got xy right here, my opposite is my y value. So I know that y is my sine of theta. So if I've got, this is 1, and my axis is going to be my cosine, but we won't deal with that right now. So let's start with those easy 4 points that we did in one of the last videos. So we have 0 degrees. We don't have a triangle, right? We have the coordinate 0, 1. Nope, forgive me. 1, 0. So if that's the case, I've got a theta of 0, and my y value is 0. So when I have an input of 0, my output is 0. Okay, let's go to 90 degrees. So let's come up here. We're going to create 90 degrees. This point is 0, 1. So if I've got an input of 90 degrees, I'm going to call it pi over 2 in radians. Then I'm going to have an output of 1. All right, let's keep going. Let's go with a different color here. So if I keep going and I create this 180 degree angle, which is half of our circle, so it's going to be half of 2 pi, which is pi. I've got this coordinate here, which is negative 1, 0. So if I've got that and my y value is 0, when I have an input of pi, I have an output of 0. All right, let's go another quarter turn. And if I go right here, I'm going to be at this point for my terminal angle. And so this is going to give me 0, negative 1. You'll notice that my y value is negative 1. So if I'm now at 3 pi over 2. And my output value is negative 1. So I've got 4 coordinates here that I can now put on my graph. So I'm going to put some increments out here. Let's do pi over 2, pi, 3 pi over 2, and of course that goes away. I just didn't like how it was ugly. All right, and then 2 pi. All right, so I've got these coordinates. I've got 0, 0. I've got, and actually let me do 1 and negative 1 on my graph. And then I've got pi over 2, 1. So that points up here. And then I've got pi 0, which is in orange. And I've got 3 pi over 2, which I think I did in purple. Yep. 3 pi over 2, comma, -1. And then we didn't do 2 pi, but you'll notice that 2 pi, when we do the full circle, has the same position, same angle, or same sign value as 0, 0. So we're going to be back to 0 for our output. So this might look unfamiliar to you, and what I'll tell you is that we're going to get something that has this sinusoidal curve, which from the name, and if we were to do some other values, what's great is, so I'm going to bring up a calculator, and we're going to take some other values into account here. So let me clear this. One thing if you use a TI-84 is you got to go to mode and you got to change it to radians to make sure that it's dealing with radians. Okay, so I'm going to do 3 other values here. So let me minimize this so I get my table up. I would like to do, since these are kind of our infamous angles, is 30 degrees, so that's pi over 6, 45 degrees, which is pi over 4, and 60 degrees, which is pi over 3. So I'm just going to put these over here so we know that's what we're talking about. Okay, and we want to know what the outputs are. So these have very specific outputs, but for our case, we're just going to use decimals to round it. So if I take the sine of pi over 6, I'm going to get 1/2, 0.5. All right, let's take the sine of pi over 4, 0.707. And we're going to take the sine of 30 degrees. Oh, 60 degrees. I'm sorry. Sine of 60 degrees. So we're going to take pi over 3, which is 0.866. So if I go back up here and I graph those, so pi over 4 is right in the middle here. 30 degrees is right about here, so that's pi over 6. And 60 degrees is a little bit closer there. So pi over 6, pi over 4, pi over 3. That's inputs. And then we've got these values here where if this is my 1/2, so we're about 1/2 right there. Pi over 4 is about 0.7, and pi over 3 is 0.866. Now, of course, that happens right then. Let's go back up. So we're like right here. And so what I'm hoping that you see is that we've got this kind of curve. So let's get a nice bright green color. We've got this curve happening. And so it's going to be symmetrical on the other side, where it's going to curve down. And then we're going to kind of curve to 3 pi over 2 and back up to 2 pi. And so then it begins to repeat itself. And that's a sinusoidal, that's the sine curve. I do want to take a look at a couple slides. So slides that I have for these, oh, and we need to answer those 2 questions. So here's a visual of what we were doing, and then I've given you a table at the bottom. But then you'll notice that I've got an input-output table here for you too, which gives a lot more values to show you how this curve is actually created. So now that you've seen us kind of go, we've gone through the process a little bit. So if I go back here, I paste this maybe right here. Is it not liking it maybe? All right, there we go. So we've got an input here and an output here. We don't need to really talk about cosine just yet, but you can revisit that. And so what we did together is we just did, we started out by doing these values. And then we went back and we did these values. We also did pi over 4, which isn't included in this table. But then you can see in the slide these other values and how they help create the sine curve. Now, if we go back up here and we look at the domain and the range, all right, the domain of this function, if you look, it's going to continue to left infinity and it's going to continue to right infinity. So the domain of the sine function is going to be all reals. It continues into infinity in both directions. And then the range, you'll notice that we never get above or below 1 or negative 1. So our range is, our y values are between negative 1 and 1. All right. And I think I'm going to conclude the video there. Let me know if you have questions.